Hi there, this is a look at some algebraic fractions. Some of this probably is almost GCSE-ish, so I'm hoping it's not too hard, but we'll soon see, I suppose. So let's have a look at this. So a starter should definitely be fairly straightforward. Simplify the following by factorising the numerator and or the denominator and then cancelling down. This is like a GCSE type question, and here you can see this first one I can write as a plus b over 4 lots of a plus b. I can factorise the bottom, and so effectively I've got 1 on the top, and that cancels with that, and so this is a quarter. What have I got here? Well, on the top I've got ax squared, and on the bottom I've got a squared x. So I don't think there's any factorising to do. I think that cancels with one of them, and that cancels with one of those. I think I've got x over the a left over. What's this one? Well, the bottom can be factorised, and you should recall that this is a squared minus b squared is the difference of two squares. And when you get that, you can rewrite that in its factorised form, which is a plus b, that's a minus b. You can see that cancels. And there's always, I mean, I had the same thing here. When you cancel, there's nothing left. You still have to put a 1, because effectively you divide in this case, a plus b. And a plus b, and you say how many a plus b's go into top and bottom. And it's exactly the same here. The expression is the same as well. A plus b. So this is 1 over a minus b. And I always get some students who forget something to do with the 1. What have we got on number 4? We've got x plus 2. Obviously I'm going to factorise the bottom. It's relatively straightforward to factorise. It's x plus 2x plus 3. So you should see there that goes, and again it's 1 over x plus 3. That's a plus. And the last one, the only thing is you notice that it's almost the same, but the minuses are the other way around. So by that I mean on this one it's a plus a, and here it's a minus a, and here it's a minus b, and here it's a plus b. So effectively I can take out on the bottom, I can rewrite the bottom as minus a minus b, and if you just look at that for a moment, minus the a, tick, minus a b, plus b, tick. So that then allows me to cancel those a minus b's out, and that gives me effectively 1 over minus 1, which is of course minus 1. So what were my answers? Yeah, all of those work. And just checking them. Yes, all of those are good. So algebraic fractions. We're going to look first of all at multiplication and division. And so again, you definitely saw this at GCSE. There were some quite a few questions like this at GCSE. But I suppose it depends what kind of group you came from. Your group might have done loads of work on this. It might have been a one lesson job. So you can see why they've introduced it here. Well, I'm going to factorise the top. But that looks to me to be x plus 2x minus 1. And if you're not very good at factorising, you can always cheat on your calculator. Type that as an equation. If you type this in an equation, the calculator would say x equals minus 2, x equals plus 1. Now, of course, I'm just talking about the top bit here. But then you'd have to bracket it. You'd have to then write it in its bracketed form by changing the signs. But I've no problem with that if that's what you need to do. X squared minus 4 is obviously x plus 2. X minus 2 is another example of the difference of two squares. Notice 4 is a square number. And here I'm timesing by. What does that factorise? That says to me it's an x plus 1 this time, I think, and x minus 2. So very similar to this. But the plus and minus are the other way around. And this, I think, is x minus 2. X minus 1. Hopefully I've got those right. There is case of crossing off top and bottom. Now they can go diagonally, so that one goes with that one. Plus 2 goes with that one. So I think I'm left then with an x plus 1 on the top and an x minus 2 on the bottom and not much else. So that should be the answer. X plus 1 over x minus 2. Yeah, good. Alright, same again. Now obviously you should remember this rule about division. There are different versions of this. But when I was at school, I was always taught to divide by a fraction. Now you need to be a bit careful of this because this is a fraction divided by a fraction. What I'm referring to is this fraction here. If you divide by something which is a fraction, you turn it upside down. And multiply. Now this is what the exact wording of what I was taught when I was, I don't know, 14 or whatever I was. And you might have seen it for the first time when you was about that age. And so you just go about this the same way. So this is x squared minus 4 over x squared minus x minus 6. But I'm now going to times by, and it says x squared minus 9 on the bottom, but now it's on the top because I'm timesing instead. And that's a simple trick that you're meant to do. And now I do it the same way as before. So there's no different now. So the x squared minus 4 becomes x plus 2, x minus 2. This is the difference of two squares. The bottom becomes x plus 2x minus 3, I think. Yep, it does. And I'm now going to times by x squared minus 9 is x squared, x plus 3x minus 3 divided by x plus 3x plus 2. And again, you now look for lots of crossings out, top and bottom, so they clearly go. That one goes with that one. X minus, so x plus 2 goes with that one, and I'm now left with x minus 2 over x plus 2. So I've got x minus 2 over x plus 2. It looks almost the same as last time, but I don't think it's quite the same. But that's the answer. So all fairly straightforward so far. Remember this division. This is taken on from what we saw last time, but it goes a bit further because we are expecting some remainders this time. So I'm going to do this long division. So x minus 2 is almost this, what we saw last time. It's the bus stop method almost, but algebraic version of it. So anyway, what do we times x by to get x cubed? I get x squared. So I now back multiply these two things, and when I do that I get x cubed minus 2x squared, and I put it in a bracket to remind me to take away. Minus 3 minus x plus 2, that gives me minus x squared. And I can't emphasize it's that those subtractions where people always go wrong. Bring down my 6x. What do I times x by to get minus x squared? I reckon that's minus x. So minus x times the x is minus x squared. Minus x times minus 2 is plus 2. Put it in a bracket to remind me to take away. And now that disappears. 6x minus a plus 2, I reckon that's like minus, I reckon that's 4x plus 5. Still not done. X times by what gives me 4x? Obviously a plus 4. 4x, and then multiply. 4 2s are 8 is a minus, so it's minus 8. Put it in a bracket to remind me to take away. Disappears the 4x's, but 5 plus 8 is 13. And this is a remainder. So what we do here, we write x cubed minus 3x squared plus 6x plus 5. When it is divided by the x minus 2, the answer is, well, what was the answer? The answer is what this quotient up here. The quotient's a posh name for the answer when you divide. But it's not exact, you see. That's the point. You see, I've still got 13 left over when I do this division. And that 13 hasn't yet been divided by the x minus 2. So I'll write it like that. Plus 13 still to be divided by x minus 2. That's what my answer says. And that's exactly what my answer says. X squared minus x plus 4 plus the 13 still to be divided by x minus 2. And you did get asked, even at primary school, I've seen those kind of calculations when it's a number divided by something, and you end up having to do a number divided by something, and with a remainder you still show that fraction at the end. So that should be fairly fairly straightforward. And really that's it. There's not much to this exercise. I'm hoping you have a look at this and think, you know what, that's quite straightforward. And it's nice to get a couple of easy ones, particularly after topics like functions and things like that, which I know, and the transformations, which are always difficult because you're not quite sure what the graphs look like. So this is quite nice. Enjoy it, and make sure you get it done. Thank you.